Hi everyone, this is Mr. Zirkle, and this video discusses solar radiation and Earth's seasons. The sun, as many of you know, is what drives most processes here on Earth. Without it, we wouldn't have the water cycle, there wouldn't be photosynthesis, and even the rock cycle would work much differently, if at all. One of the biggest effects the sun has on our daily lives is its effect on our atmosphere, which is driven by the input of energy from the sun. Incoming solar radiation is the amount of energy that strikes a surface over a given unit of time. Now, before we move on, I want to make a quick note here and let you know that we usually call this by another name, insolation. Insolation comes from parts of the word incoming solar radiation. Generally, the units of insolation are expressed in one of two ways. One unit is kilowatt hours per square meter per day, which represents the average amount of energy hitting an area each day. Another form is watts per square meter, which represents the average amount of power hitting an area over an entire year. Not all of the solar energy that reaches Earth actually reaches the surface of the Earth. Although 1,367 watts per square meter of sunlight strikes the outer atmosphere, about 30% of it is reflected back into space by the upper atmosphere. After this reflection, a certain spot on Earth might receive almost all or almost none of the sunlight. There are many factors that help determine how much sunlight actually reaches a given area. One of the major factors is the angle of incoming solar radiation, which has a lot to do with the latitude of the location. For example, you can see here in the tropics that one unit of energy hits the surface head-on at a 90-degree angle. This means that the insolation is most intense here. However, as you move to the mid-latitudes, you can see that one unit of energy is actually spread out over an area of about 1.4 land units. This means that the intensity of the solar radiation must be less, since you're taking that energy and spreading it out over a larger area. When you get to the polar regions, that one unit of energy is actually spread out over 2 units of area, causing the poles to receive less even than the mid-latitudes. In general, as you move away from the equator, incoming solar radiation decreases, as you can see here. In addition to the angle at which it hits Earth's surface, another major factor in the amount of insolation a location receives is the length of day, which is directly related to the seasons. Now, at this point, we want to take a few minutes and remember back to what we were taught in ninth grade Earth science. First, it's important to remember that Earth's orbit is not circular, it's elliptical. Because of this, the distance from Earth to the Sun varies throughout the year, depending on where Earth is in its orbit. More than a few people, erroneously of course, believe that this change in distance causes the seasons. After all, it does seem to make sense that if you're closer to the sun, it's going to be warmer. However, if we actually look at Earth's orbit, we can see that perihelion, which is when Earth is closest to the sun, actually occurs around January 3rd, in the middle of winter. Aphelion, when Earth is farthest away from the sun, occurs in the summer around July 4th. This proves that distance from the sun doesn't have an effect on Earth's seasons. So, then what does? Well, the answer lies in the tilt of Earth's axis, also known as its inclination. Earth's angle of inclination is 23.5 degrees. For us, summer occurs when Earth's northern hemisphere is tilted towards the sun. Winter occurs when the northern hemisphere is tilted away from the sun. During the summer, days are longer and the angle of insolation is greater. During the summer solstice, the longest day of the year, a location in the northern hemisphere would receive the most incoming solar radiation. Alternatively, during the winter solstice, the shortest day of the year, a location in the northern hemisphere would receive the least incoming solar radiation. Lastly, besides the angle of insolation and the time of year, the amount of incoming solar radiation an area receives is also determined by the transparency of the atmosphere. Cloudy or hazy days will see an area receive much less insolation than clear days. All of these factors combine to heat the surface of the atmosphere unevenly. Although you can see a general trend of high amounts of insolation and heating at the equator with lesser amounts toward the poles, on any given day due to the current weather, the heating of the surface may change. This will result in an important concept to keep in mind as we move forward. And that's, again, that the Earth is heated unevenly. All right, well, that's the end of this video. If you have any questions or concerns, please message us. Otherwise, we'll see you soon.